is from GATE 2021 XLS, question number 15 for 2 months. So, the figure shows the profiles of quantitative real-time PCR (QRT-PCR) tests for SARS-CoV-2 conducted on the throat swab samples of three individuals, X, Y, and Z. So three separate individuals are taken, throat swabs are taken, and the QRT-PCRs are done. Tests were carried out under identical conditions. Dotted lines represent the threshold fluorescent value. Identify the correct statement on the status of COVID-19 tests of the individuals based on the QRT-PCR profiles. So the y-axis denotes fluorescence and x-axis denotes the number of cycles. So what are the options? The options say that x and y are negative and z is positive. Next option, x and y are positive. There is no apparent difference in the viral load. C, X and Y are positive, X has the highest viral load. D, X and Y are positive, Y has the highest viral load. So, what is the answer to this question? First, so what happens is if we consider the central dogma again, so from DNA, we have the mRNA and then we have the protein. So, what happens in QRT-PCR or reverse transcriptase PCR? We take the mRNA and then we produce the so in some viruses as SARS-CoV-2 we have the mRNA or RNA viruses. They have RNA as their genetic material. So because it is difficult to quantify mRNA or RNA because of its instability, what we do is we convert it to cDNA or cDNA samples, and that is complementary DNA of the mRNA, and then we quantify the level of cDNA in present in the, say suppose that individual or anything and or any organism, and then we quantify it. So what we do is we take the samples DNA or cDNA containing the specific target. Here we take the throat swabs as the sample. I so for the quantitative real-time PCR, what we do, we take the throat swabs, we isolate the RNA from the throat swabs, convert it into cDNA, and then we perform QRT-PCR to quantify the amount of cDNA or amount of viral load which is present in the sample or in the individual. So what we do, because it is real time, it gives the fluorescence or quantitation value in real time, and to do that a fluorochrome is added. Fluorochrome will fluoresce only when PCR product is synthesized. So what is happens, fluorochrome normally we use cyber green. So this is the, if I say this is the cDNA strand, and here we add the primers. So these are the cyber green molecules which are freely floating in the solution or the buffer medium. So upon annealing and extension of the cDNA and the second strand is made, what happens is that cyber green gets incorporated into the within these two DNA strands. So okay, this double stranded region, it gets incorporated into them, and as it elongates, more and more cyber green molecules will get incorporated into the strand. So at the end, so you can see we start with one molecule of cDNA. After one cycle, we have two molecules. After two cycles, both of them will continue to elongate. We'll have four cycles. Okay. So three cycles, 2 to the power 3, that is 8 molecules. For four cycles, we'll have 2 to the power 4, that is 16 cycles. So as the number of as the number of molecules are increases, the number of cyber green which gets incorporated into each of these molecules, they also increase exponentially. So after n number of cycles of the QRT-PCR, you will have 2 to the power n molecules. So here we see that you are starting with one molecules, but if if the starting material if the starting material is more, then the number of molecules at the end of each round will also be more. So here you see, after the PCR reaction, what we do is that we measure the fluorescence and we measure the number of cycles, and there is a threshold value. So what does this threshold value signify? That we consider fluorescence, we consider the fluorescence of the samples only when it goes above a certain threshold value. The samples for which the fluorescence does not cross this threshold value signify that they are something is wrong, or there is unspecific, or the template is not present, or something is wrong. So we do not consider those samples. So in this case, you see there are four different samples, and there are four different CT values. What are CT values? They are the cycle number. So this uh, so what will happen is, here you can see that CT4. CT4 is the first one to cross the threshold value. It can cross the threshold value at earlier cycles. So this cycles, they start with 0, like say suppose 1, 2, 3, 4, and it goes on in increasing number of cycles. So this the sample which crosses the threshold value earlier, that signifies that the number of cDNA molecules that were more in that sample. That is why more number of cybergreen was incorporated, as as amplification was more, and they and together they could cross the threshold value earlier. So more closer to the origin will mean that less number of cycle, and so the uh, starting sample, or the starting the template was more in that sample. That is why it could cross the CT value more, cross the threshold value earlier. So coming back to the question, if we say X, Y, and Z, so Z, the fluorescence graph of Z is well below. This is the threshold line. The fluorescence graph of Z is well below the threshold point. So we can say that the individual Z did not have SARS-CoV-2 virus, and it is negative. So X, so Z is positive, X and Y are negative. This option is completely wrong. Z is the negative. So, and because X and Y both have crossed the threshold value, they both are positive. So all the other three options, they say that the X and Y are positive. So answer could be between any of the three. So now we have to say, now then we have to look at the viral load. So B says that there is no apparent difference in the viral load, but that is not the case. If there was no difference in the viral load, then both will have the same CT value. But here we see that the X has a lower CT value. X has a lower CT value than Y. That shows that demonstrate that X, the starting cDNA was more. Okay, that is why the more cybergreen could be incorporated into the PCR cycles of X than Y. Okay, Y had only 2 and X had 3. So after first round of replication, we'll have 6 molecules like that, and it will have 4 molecules. So in that way, in every cycle, amplification will be more for X rather than Y. So X and Y both are positive, but since X has a lower CT value, that means that the starting sample was more in X, and that is why we can say that X has the highest viral load and not Y. So the answer will be C. The answer will be C. So here you have to consider three things. You have to consider the threshold value. The ones that are above the threshold value are positive. The ones that are below, they are considered negative. In this case, if it is negative, that is, we say that the sample did not have SARS-CoV-2, or the individual does not have SARS-CoV-2, but if it is positive, then we check at what CT value the fluorescence is goes above the threshold point, and accordingly we can say how much viral load a person will have. So the answer here is C.